All right, so you have become a master, I think, of translations when a shape is moving this way and up and down and so forth. And then you become a master of reflections when you have a shape and it can reflect over an axis. By the way, this one's reflecting over the X axis. And then if I did it like this way, it would be reflecting over the Y axis. So we've done all that stuff. Now, there is another kind of movement that happens, and it's called a rotation. It would look like this if we were doing it with our hands. It would be turning, and I can't go far enough, but you can see that if you could twist all the way around, then the thumb would keep changing its direction. And I guess a better way to show you might be like this. If I had this particular shape, this particular triangle, and I wanted to rotate it around the center, this is the origin, and that is what all of our rotations are going to spin around, then it would just go and go and go and go, and you can see how the shape keeps its shape. It's just spinning around that center point. A couple things that are interesting are that right over here, like the C is on this far outside corner, and the A is on the inside, and the B is on top. But then when I start spinning, some of the placements kind of change, meaning now B is on the bottom, and A is still on the inside, but now C is out here at the bottom left. And it's because this movement changes a shape's orientation. It changes the way it's pointed. It changes the way it kind of sits on the graph because it's spinning around. Just like if I were here and like this was my shape and I'm spinning around, my arms keep facing a new direction. That's kind of the principle behind it. So a couple things you need to know about a rotation. First one is this. Rotations are measured in degrees. So if I move it this way, eventually I'll get to a number that's 90, and that means I moved it 90 degrees like a right angle, and that's about 1/4 of the way around the circle. If I did another big step, it would go from 90 to 180, and that would move it about halfway, not about, exactly halfway around the circle. The next step forward is a 270, which is 75% around the circle, or 3/4. And then if I kept going, I would land all the way back at 0, which would be the same as 360 degrees, which is a full rotation around the circle. However, when somebody says, I'm going to rotate something, and they give you a degree, like let's say if I asked you to rotate something 90 degrees, that would be this way. I just went 90 degrees that way, or I could go 90 degrees this way. I know those numbers aren't showing 90, but it's still a 90-degree angle all the way down here to about there. Okay, so I went from there down to there. The problem is we're used to saying words like up, down, left, right. But in rotations, you're not going to say up, down, left, right, because right now the shape is going down, now it's going left, now it's going up, now it's going diagonal, now it's going right. Like as you move the shape, it changes whether it's going up, right, left, down, and so on and so forth. So the term we use to talk about which way to rotate something is the word clockwise and counterclockwise. So clockwise means in accordance with the way a clock moves. And you've probably seen a clock before, a face clock, and the hands of the clock just spin around this way. Okay, they're always moving this way. And so that's clockwise. If I'm rotating clockwise, I'd go like this, round and around. If I'm rotating counterclockwise, I go like this. Okay, some people might think of it as forwards and backwards, but the terminology we're going to use is clockwise and counterclockwise. And then you'll be given a number of degrees on how far to move it. And it's either going to be 90 or 180. Every now and then you might see a 270, but probably not. So here's the thing about a 90. If it says 90 counterclockwise, you go that way. If it says 90 clockwise, you go this way. But if it says 180, it doesn't matter which way you go because either place will land you right over here on the opposite side, just like that. Okay, recap. Rotations spin around the middle, spin around the origin. They're measured in degrees, either 90, 180, or maybe 270, and they are directed by the words clockwise or counterclockwise. Now, the bad news is to actually do a formula on this and to spin everything the right way, or maybe even just to do it by eyesight is really tough, especially if you get like a weird shape like this. Like imagine trying to spin this thing around and, I think I just messed it up. Imagine trying to spin this thing around and get it in the right spot and put all the A's and B's and C's in the right spot. It'd be hard. It may be simple with a small triangle, but it can get more complicated. So in order to help us with this, we have a little tool that we call patty paper. Patty paper is like a thin tracing paper. You may have it around your house because some people use it to put between pieces of cheese or meat or stuff like that. So we're going to change the orientation of this video and let you see how to do this on the patty paper. Miss Walton, I'm not getting the menu option to flip the camera. I guess we can't do it in mid-video. So we're going to have to splice it. Bye.